So, what can we take away about linking theories using the kind of quantitative approaches that I've been talking to you about? Well, here's what I think we learned. Right, so again, we're looking at different types of proposals that involve either innate or derived knowledge of links, that involve either fixed thematic representations or relativized thematic representations for how it is that we come to interpret things like the little girl blinked the kitten on the stairs to mean something like this, right? How do we make those links? And so one thing we learned is that linking theory proposals that rely on innate knowledge, like the classical forms of Utah and Rutah, seem to require late maturation of the linking knowledge if they're going to be compatible with what we know about English children's developing verb knowledge, right? So that's one thing. And second, linking theory proposals that rely on derived knowledge of that link, right? They're sort of derived mapping equivalents, are also compatible with what we know about English children's developing verb knowledge. So these are perfectly viable options that really ought to be given more consideration theoretically. So that's kind of cool. And in particular, we kind of put our money where our mouth was when it comes to the derived mapping approaches, because we actually were able to provide an existence proof for how linking knowledge could be derived from realistic English child input. And importantly, it only seems to work for learners that rely on relative thematic representation. You can only get it to work out if you have this kind of representation and not this kind of representation. So it seems to me that can be interpreted as developmental support for theories of relative thematic representations over theories of fixed thematic representations for what's going on in people's minds. So, okay, fantastic, lovely. Now what? Well, a couple of things. One, these results are based on a certain collection, a nice collection, but a certain limited collection of empirical data. And one of the things that I think would really be important to see if these results hold up is a broader assessment of children's verb class knowledge, because this allows us to further validate our developmental modeling results for these theoretical proposals. In particular, it turns out that there are nearly 200 verbs in each age that we have developmental model predictions for on the basis of children's input, but no behavioral data for, right? So if we can get more of that, we can actually fine-tune our target state when it comes to verb class knowledge. Moreover, we can also build models that incorporate more cognitively plausible assumptions. So again, our current model here, in this case, was using different types of information. It was using idealized inference to accomplish that hypothesis search, as it were. But we can do more cognitively plausible things to see, again, if these results still hold up. So if we make more cognitively plausible assumptions about the child's intake and inference, what they can actually suck in from that input, right, on the base, given their limited memory and limited processing, how they're able to actually accomplish Bayesian inference, what kind of approximations they're capable of, how close they get, right? We can build those in to future models to see if our results hold up. We can also build in more cognitively plausible assumptions about the children's developing grammar, so what information they may additionally be sensitive to at 4 and 5 that maybe they weren't sensitive to at 3. Remember, the types of information we used were animacy, these thematic representations and links, and syntactic frames, but in fact we know that children's syntactic knowledge gets far more developed at 4 and 5, so they may be taking in different types of knowledge syntactically, or taking in more knowledge than what we were able to do here. And then what about the target states? So in this case, we were predicting verb classes, for example. But in fact, the behavioral data we have is something that we could ask our models to predict in the actual experimental context, where we got all of this individualized verb data. Well, what do our modeled learners do in these very same experimental contexts? What predictions do they make about the behavioral data? Do they match the behavioral data already available from children in these experiments? Because doing this will allow us to, again, provide a further validation or evaluation of these developmental modeling results. And I think perhaps more interesting from a theoretical perspective, are there other theoretical options for linking thematic information to syntactic structure that are compatible with what we know about development, right? So we had a certain idea for what a fixed representation looks like taken from the literature, a certain idea of the relativized one, but you can imagine there are many other options one might consider, and we can look at them, right? And we can see, are any of them better than what we're seeing here? Do any of them give us different types of developmental stories for what we would expect? And the point being that we can use the very same quantitative approaches I've shown you here to investigate them. So more generally, what I'd like you to take away is that these quantitative approaches allow us to connect theories of linguistic representation with theories of how those representations develop, right? Of theories of language development, that process. And so allow us to understand more about both in the context of an integrated theory of language. And so with that, I think I will close, and I will thank you all for watching, and I will thank all of these people, audiences here, my lovely collaborator, John Sprouse, and my Computation of Language Laboratory, and all of my lovely people who helped me create the Childress Tree Bank corpus, which is where I got all the delightful input data, and of course the National Science Foundation for funding this. So thanks.